Just wondering.
Paparazzi. Yeah, he's paparazzi.
I'm Noelle Osborne, and let's see, I have a bachelor's and master's degree in geology, but I spent most of my career doing water resources work, hydrology. I worked at the Oklahoma Water Resources Board for 22 years. And while I was there, I was able to manage the Arbuckle Simpson Aquifer Study. And then I worked for the U.S. Geological Survey at an Oklahoma Water Science Center in Oklahoma City. I worked there for close to 3 years. And then I've been with the National Park Service for, I'm going on my 5th year.
2 years already. You know, it seems like I've
Well, I mean, I just started my 5th year.
Amy Ford, and I have no idea how I got into water other than I went to one meeting and I was in did healthcare. Same dynamics going on in our house. My husband will just like, oh, okay, you lost me, yes. Yeah, so, but I am president of Citizens for the Protection of the Arbuckle Simpson Aquifer. That's how I got, I'm assuming taking this seat right now. Been that for, I don't know how many years. I was treasurer for years. Went to one meeting as treasurer, and then I've been president for, how long have you been with CPASA?
7 years.
7 years, so probably close to 10 years now. I do a lot of the policy advocacy efforts. I'm the drum beater and get called a lot of names, and I'm okay with that because there is a huge gap between science and the policy, and it's a challenge to push that rock up the hill. But that's kind of the way. That's what I do. You know, I get to work with this one every day. We've had her since she got out of law school. I feel like we've raised her. So yeah, that's why I'm in water. And I have a ranch that is southern boundaries with Blue River. So I talk with my hands. They're in my pockets right now. The Blue River is my south boundary of my ranching operation, and so that's ultimately what I went into the room to try to protect. So
The Blue River emanates from
the Arbuckle Simpson, born in the Arbuckle. So it was a great concern to me what could happen to that. So that's why I walked into that room that first day, and I've never known. Hey, welcome.
Good to see you again.
Good to see you too. It's your turn.
Oh,
Who you
great.
are. Tell who you are.
I am Jonathan Allen. I am one of the staff attorneys for the Oklahoma Water Resources Board. And I was involved in the appeal side. When the maximum annual yield determination proceedings were done, they were immediately appealed, and that's when I got involved. So,
Lucky you.
yeah.
Charles Reyes, I'm the landowner over the Arbuckle Simpson. And I feel like I've been to law school.
Don't you? I know. I feel like you know more about water law.
Law
than
school's
you
only
do.
3 years. so-
We're just slow learners.
Yeah.
20 years it's taken us to get here.
I'll probably be the most boring speaker here.
No.
Not at all.
So they have a basic understanding of equal proportionate share.
Yes.
So if we say EPS, because I never know how.
So we talked about all of that last week, generally about the maximum annual yield process, about how the water board has to do a hydrologic study and then set a tentative maximum annual yield, then have the public hearing and comment period, then do the final determination, then the appeal process. And I think it's going to be great for them to hear from all of these different perspectives. Every one of them is valid, right? I mean, everybody has a valid interest in the Arbuckle. It's how do we get along with each other, and how do we make policy that's the best for everybody, and what does that look like, and how do we do that equitably? So each of them are going to have a different perspective to talk about from their interest, how we did that or didn't do that, what we could do better, kind of what we're looking for in the future. some things that were concerning, or some things that they thought went well. All of it is valid, and it's important for us to listen to all of the sides so that we understand going forward how we can best work with each other to amicably resolve issues instead of, going to litigation at every turn. Because even though I'm an attorney, I don't advocate for lawsuits. It's not something that I generally am like, yes, let's just sue them. Generally, that's not in your client's best interest. You should work it out first. So, Noelle, we'll start with you. You've got a couple different hats here.
I do. It's mostly science, I'm afraid.
Well,
And I don't know how much you want to get into. So this, managing that study took, several years of my career.
so tell us, how did you come up with the study? Where did you start?
All right, well, I'll start working on it. If it gets down a track you don't want to go, just okay, let's move on or something. But I did an outline to sort of organize my thoughts. So, well, I've been doing aquifer studies for a long time for water management. And in 2003, when Senate Bill 288 was passed, I started working on the Arbuckle System hydrology study. That was what we named the study since we were directed to do a basin study to determine how much water could be withdrawn from that aquifer without reducing flow, natural flow. So I'll talk about what problems that terminology caused for us. But we started the study in 2003, and it's a 6-year study because we basically went from 2003 to 2009, and it was almost $4 million. It was paid for by the state and the Bureau of Reclamation, the U.S. Bureau of Reclamation. So early on, I said, okay, we did this study, woo-hoo. What do you do? Well, I started tapping expertise. I went and talked to Dr. Todd Callahan at OSU. He was a brand new hydrology professor up there, and I hadn't met him, but I knew that he had done work in the Edwards Aquifer in San Antonio. So I thought, I'm going to go pick his brain. So I went and talked to him, and then I invited him down and to the office, and I said, well, I'd like to come, but I'm going to bring some other people with me. I went, okay. He brought 5 other professors from OSU, and I went, oh my gosh, what am I getting myself into? He brought a sociologist. He brought computer specialists for data management. He brought engineers, a whole range of things, and they were looking at doing more of a, multidisciplinary type approach to water issues in Australia. And so here was this team. They showed up, and we talked for a while, and one of them finally said, you could do the best study ever, the best science, but if you don't involve the public, and if you don't, identify your stakeholders and really involve them, it's just going to sit on the shelf and it's not going to really mean anything. And that really meant something to me. So I think right there, that helped form some of the things that we did. In fact, part of that reached out to the Bureau of Reclamation because they were a partner in this, and they had done a lot of public involvement work. So they gave us a little one-day public involvement 101 class. So identify your stakeholders and what types of information. Are we going to provide information? Do we get feedback? We came out with an outline to do that. This was the Water Board had not done any type of public involvement ever. So in fact, they sort of shied away from it. Our director at the time had been burned by some really controversial issues. We were trying to sell water to Texas. That didn't go over real well. There were the hog farm issues in the Panhandle, and so there were a number of things where he really didn't want to be involved with the public. But we sort of forged new territory and came up with a plan where we would do newsletters and talks to Rotary clubs and things like that, and CPASA, right? And different stakeholders, and keep them informed. We also formed a a team. We had a technical peer review team, is what we called it. I reached out to different expertise. I think there's a lot of skepticism that the water board could do a study on this scale. You know, and it was pretty comprehensive, although at this time, I'm still thinking geology, you know, and water. And so I picked this, we selected a team of experts, but they're all geologists. So there was Dr. Hallahan, Dr. Neil Sunnison, who's with Oklahoma Geological Survey, Dr. Randall Ross with the Kerr Lab, and Scott Christensen with USGS. So all four are groundwater people or geologists, which seemed appropriate at the time, but in hindsight, we really expanded our field of expertise to a much broader scale. And we also had some liaisons. Dick Scalf represented users and PASA. He was present at most of those meetings, and Clayton Jack to represent the landowners. They also were at the table. So we would have these periodic meetings where we would try to figure out, okay, you know, what do we need to do, you know, and review what we had done and where the data gaps and things were. And when we all came together, and we came from different parts of the state, but we really, really focused and got a lot accomplished during that time. But over time, we had this huge multidisciplinary team. Over 30 scientists worked on this project. There were geologists, geophysicists, geochemists, surface water and groundwater hydrologists, meteorologists, biologists, engineers, sociologists. A lot of different kinds of professions were involved. And it's also ended up being a pretty multi-agency, not just the Water Board, the Bureau of Recs, the USGS, the EPA, Oklahoma Climatological Survey, OSU, OU. We had many masters and PhD come out of this program. A lot of student activity, and Chickasaw Nation is another cooperator. So in the end, this is, I think, the most studied aquifer in Oklahoma ever, by far. We did a lot of stuff. In 6 years, we did quite a bit. We monitored groundwater levels, in wells, the first thing we did was install stream gauges at Blue River, Pennington Creek, and Honey Creek was the third one. That was the very first thing we did. We did that in 2003, and it was the smartest thing we ever did, because that actually measured the water that was discharging from the aquifer. It was key. It was key in the modeling and what we were doing. So we were able to get right off. We were able to start getting that stream gauge record. And when we did the model calibration, it's calibrated to Blue River and Pennington Creek, right at the edge of the aquifer, right where those rivers come off of the aquifer. So just to give you a little background on how an aquifer works, I discovered early on when I talked to any group, I had to make sure we had the same basic knowledge of groundwater, because most people don't know much about groundwater. You know, I mean, most people don't know about it.
Yeah.
It's hard to believe. They don't. You know, it's out of sight, out of mind. Why would they know anything about it? So I had this little diagram I would always show. I mean, it didn't matter who I was talking to. I never assumed, because if they didn't get the basic concepts, they didn't get it. So I had this little cartoon, you know, here's the aquifer, here's water coming in, water comes in, some of it floats down and it comes back out. It's, you know, base flow, right? You've seen that cartoon
I think I've shown that to them at the beginning of the year.
Okay, right. But, you know, there's recharge and there's discharge and there's base flow and, you know, flow lines. And so just having people having that basic understanding was pretty critical. So, you know, we did stream flow, we looked at climatic conditions, we installed at Fitztown Mesonet Station, we drilled a well there so we can tie the water level in with the meteorology. We did a 300-year analysis of tree rings where we were able to reconstruct the hydrologic flow for 300 years. Because someone asked at one of my presentations, they said, well, because I would show this little graph showing, you know, the last 60 years of flow and how that correlated with the climate. And Dr. who used it up and said, well, wouldn't it be great if you could take it back farther than that? And I said, it would be great. How would you do that? He said, treating. So he did that analysis. We did a lot of different methods to determine aquifer parameters, things like storage coefficient, transitivity that we need to have to evaluate groundwater flow. We evaluated petroleum-related information, deep wells that had been drilled in the area. Dr. Puckett from OSU did a lot of analysis of that. We drilled some test wells and we sampled those wells. We did dated how old the water was. You can do that. Geochemistry. We did different types of geophysical surveys, helicopter electromagnetic surveys, helicopter flying over the aquifer, gravity surveys, and we analyzed the seismic line. We did geochemistry, isotopic age dating, an in-stream flow assessment to quantify fish habitat in Blue River and Pinto Creek. And we constructed a three-dimensional ground geologic framework model, which served as the basis for the groundwater flow model that we later did. And that was a key component. All of this information eventually, or most of it, fed into the groundwater flow model. Because to really understand what the effect of pumping wells on the aquifer, we just can't go out there and start pumping them. You know, we use models to do that, to simulate it. But you want to make them as good as you can get. So Scott Christensen with USGS did that work. At the end, we had generated over 30 reports. The primary one that describes the modeling and pulls a lot of that together was the USGS Scientific Investigation Report 2011-5029, Hydrogeology and Simulation of Groundwater Flow in the Arbuckle Simpson Aquifer. So, and that's available online. If you want to know all the technical details, that's where that is published. So, anyway, after all this work, you know, we come to the maximum management hearing. And yeah. So I'll talk a little bit about that. You know, the problem that caused me and our team as scientists was that Senate Bill 288 says that, you know, the Water Board needs to come up with a maximum annual yield that will ensure that any permit for the removal of water from the groundwater basin will not reduce the natural flow of water from springs or streams and from the basin. And what do you mean by not reduce natural flow? If you're not going to reduce flow, you can't pump, period. Because when you start pumping, that's water that's not going to go out to a stream or a spring. But we did, you know, we knew that some amount, you know, of pumping is necessary. So, but what do we measure? You know, so we can model what's going to happen when you pump out water, but we don't know what the target is, and that was always a big issue. I think they said, "Oh, just, you know, turn the crank and this number pops out." And said, "Well, we need the target. How much flow do we want to maintain? Does it need to be base flow, a certain amount of base flow? Does it need to be a certain amount of the total flow? Are we looking at specific streams or the whole aquifer? How, you know, what exactly do you want here?" Well, no one really knew. We formed a surface water committee to come up with, okay, what should we aim for? And you know, we had USGS and National Park Service and Nature Conservancy and DEQ and the Oklahoma Department of Wildlife Conservation, Conservation Commission, and Fish and Wildlife Service, and landowner too. I mean, so we had all these different people. Well, Fish and Wildlife Service said, you know, basically it was such a tiny amount that we could withdraw. It wasn't going to work. And Joy said, I want to see that. That's not reasonable. You know, so just looking at fish wasn't going to cut it. And so that, I mean, it really was an issue at some point. And then it took us all the way through the maximum annual yield hearings. When finally, when we went through a couple directors of the Water Board, they finally said, you know, the final decision was based on science, but that number was not science, it's policy. And that's a policy. They don't want to admit that. They really wanted it when it all on signs. Every single director wanted.
Couldn't do that though.
Right.
It's impossible.
It was impossible. And I was, at that time, I was with USGS, and I couldn't say, oh, God, science told us that. No, you know, that's the policy.
I was on the other end of that
You're on
argument, going,
it.
okay, I can't sell that number.
Right, right. It's just like, no, you know, this is a number that, you know, is reasonable. They finally had to say that, oh, yeah, well, it's just,
And the problem was the number was so low
we're so low.
that our concern was that we would have all this massive revolt with those in the Arbuckle that were using the water